discussed about multiplexer and then decoder and then half adder, full adder, half subtractor, all these things, right? So today we will discuss about demultiplexer. What is the use of demultiplexer? Okay, demultiplexer performs the reverse operation of multiplexer, right? So multiplexer means we are having multiple inputs, right? And then single output we are getting. But demultiplexer is the reverse operation. We are having single input, okay? We are having single input, then select lines are depends on same type. So what are the outputs are there? So based on that only we need to select the select lines. Suppose 1 by 2 power n, okay, 1 by 2 power n, this n defines the select lines. Okay, these are the select lines. So n number of select lines we are having. The data input is nothing but single input we are giving, multiple outputs are getting, right? D0, D1, D2, D3 and so on, so Dn minus 1. Okay, what is the example of demultiplexer? Suppose a radio you can consider means only one transmitter, okay, one transmitter, but receivers are many, right? So while listening the radio, the receivers are many we have. Okay, that is the demultiplexer example. Suppose demultiplexers, one channel is there, multiple broadcasting channels are there. Broadcasting means TV9 is one channel, single channel, but receivers are many. Okay, so one channel is there, but receivers are many. That will be related to demultiplexer. Okay, so then demultiplexer having data input and then select lines and then output lines. Okay, output lines, one single input we are having and multiple output lines we are getting that. Okay, those multiple outputs are depends upon the, suppose I want to design 1 by 2 demultiplexer. Okay, so that means one input, one select line, two outputs. Okay, so just 1 by 2 DEMUX I want to design. Okay, one input, that is my data input. Okay, and then select line is one select line, and two outputs I am getting, I0, I1. Okay, or some Y0, Y1 you can consider that anywhere. Okay, inputs we are considering as in I1, I2, outputs we are taking as a Y0 and Y1, right? So input is equals to select line equal to 0 means your input should be 0. Okay, and then select line is 1 means your input should be 1. Okay, depends upon the select line which one is selecting, output side Y0 or Y1. Okay, same thing. Just see, this is the 1 by 2 demultiplexer. We have an enable pin also. Enable pin is selecting enable equal to 1 means, okay, you are giving the enable pin. This enable pin is 0 means the select line is 0 or 1. I don't care about that. My output is Y1 or Y0, both are zeros. Okay, and here whatever the input I am getting, suppose enable pin is 1, select line is 0 means whatever the input I am giving, that input is getting at the Y0 side. Okay, because 0 means Y0 is selecting. Okay, if your enable is 1 and then select line is 1, my output is getting at that Y1 side and then Y1 is 0. Okay, so in this way we are writing that output equations. Then Y0 equal to, what is the equation here, S0 bar into A, and then Y1 equal to, what is the output equation, S0 into A. Okay, so that is the representation for demultiplexer. Circuit diagram also same type of representation. How we can represent the circuit line means select line I will consider here S0 and then S0 bar, and then consider one AND gate. Okay, so this AND gate is connected to, what is the input A, and then S0 bar. Okay, this is S0 bar. We can connect here, and then I am getting the output Y0. Similarly, another AND gate you can consider that. Okay, so you can connect that input A. Okay, and then out S0 bar, sorry, S0, and then y1 equal to, what is the output equal here, s naught into a, and then y naught equal to s naught bar into a. Clear? Any doubt from 1 by 2 demultiplexer? See how it is working like a decoder. See, decoder I have already explained, right? Decoder is n inputs are there, 2 power n outputs are getting, right? N 2 power n. So here also one input is there, select line is 1. Okay, so that means 1 by 2 power 1. Okay, so 1 by 2 power 1, it is act like a demultiplexer, right? Okay, so 2 by 2 power 2, that means 2 by 4, 2 by 4 decoder, that is also demultiplexer working. Okay, so decoder is also act as a demultiplexer, or demultiplexer is also acts as a decoder. Okay, see, uh, this input also we are having one input A. Okay, so 1 by 4 demultiplexer, that means 1 by 2 power 2, two select lines are there, S0 and S1, and then input A where we are getting. So 0 0 means Y0 is selecting here. Okay, then input will be appeared at y0 channel. Okay, 0 1 means y1 is appearing, then input will be appeared at y1 side, and then 1 0 means y2 side, input will appear at that y2 side, and then 1 1, so input will appear at y3. Okay, so this is simple demultiplexer for 1 by 4 demultiplexer. See, decoder is also working same like, right? So two inputs I am taking, so D naught, D1 is the inputs, and then Y naught, Y1, Y2, Y3 are the output. If 0 0 means Y naught is selecting, 0 1 means Y1 is selecting, 1 0 means Y2 is selecting, 1 1 means Y3 are selecting, and rest of the things are zeros. Clear? So this is 1 by 8 demultiplexer. That means again 3 inputs I need to consider, that 3 select lines, because 1 by 2 cube, 3 select lines we are having, S0, S1, S2, and then 8 outputs. Okay, single input we are selecting there. Okay, so if all are zeros means 0 0 0 means S Y0 is the input, and then Y1, Y2, Y3, Y4, Y5, Y6, and then Y7. So diagonally we are getting the outputs, because based on the select lines we are getting one output at a time. That output will be presenting output side based on the selection of input lines. Whatever the select lines you are selecting, based on that output will be appeared at. Whatever the input you are giving, that input will be appeared at the output side. Clear? So this is the decoder operation, same thing. Whatever the demultiplexer 2 by 4, that means 2 by 4 decoder is working, right? So 1 by 4 demultiplexer is also working like same thing. Okay. So encoder means, what is the use of encoder here? Encoder is having n number of inputs, sorry, 2 power n number of inputs and n number of outputs we are getting there. Okay, so what are those? N number of 2 power n number of inputs we are getting, right? Just 2 power n number of inputs I am getting. Okay, so then these are all inputs. That means suppose 4 inputs I am taking, like y0, y1, y2, y3. Okay, it depends upon the 4 inputs, means 16 combinations we are getting, right? So then we are getting every time how many outputs? So 4 inputs we are giving, 2 outputs we are getting. Okay, so 2 outputs means either y0 or y1 we are getting. Okay, that is the encoder operation. Simply encoder, what it is doing means, it will convert what type of conversion it is doing that. So some decimal inputs we are getting, right? So that will be converted into characters. That means machine understandable language should be, human understandable language should be converted into machine understandable language. So human will gives you like digits or alphabetics or characters. All these things are converted into binary representation. Okay, decoder is reverse operation, right? So decoder, what it is doing that machine understandable language should be converted into human understandable language, right? That is the decoder operation.
Machine understanding language is converted to human understanding language by encoder. And encoder.
Decoder, that is the decoder operation. Encoder, what it is doing that
Okay.
human to machine.
Human.
Uh,
Whatever you can type in ABCD.
so whatever the text or numbers or any images, okay, all these things should be converted into binary format. Binary 0 1 0 1 0 1 1 1 0 1. In this way, the binary values will be converted. That is the encoding part.
So the encoder part is for the machine. Okay. So I was taking it otherwise.
That is taking
I thought encoder is for us.
and
Encoding is for us.
decoder
Not
for
for us.
receiver side. Okay.
Okay.
So encoder we are using at the transmitter side and decoder is used at the receiver side. Suppose we are transmitting the data, so this is transmitting data and then here encoder is there. Okay, and then it is giving to some communicating channel. Okay, so communication channel it is giving that and during that it will be decoder will be there. Okay, receiver side decoder will be there and then receiving the information. So this will be the happening. Okay, this encoder is converting that human understandable language to machine understandable language and this is reverse operation. Machine understandable to machine to human. Okay.
That's why if you talk or if you text anything or email. So email goes the same way or just the text messages go the same?
Both are all the things will be converting. Okay, so whatever the information we are sending, that all should be converting. Okay, see 4 by 2 encoder, 4 inputs I0, I1, I2, I3 I am giving, and then Y0, Y1 are the two outputs I am getting here. Okay, so here what are the inputs I0, I1, I2, I3? One input we are selecting at a time. So then if you are selecting at the I naught and you are getting the output is y 0 0. See how we are saying that this is the binary number but decimal number is 0 1 2 3, right? So 0 1 2 3 format it is storing that. If you are selecting the I naught means what is the decimal value of I naught is 0, right? So that is the 0. That's why the binary is 0 0 we are selecting that. Okay, and then I1 means 1. Okay, 1 means binary, this is the decimal value 1. Then how we can represent the binary? 0 1. Okay, I2 means 2 and then the binary value is 1 0. And again I3 is 1, again 1 1 we are selecting that. Understood how I am saying that? Same thing. Then output equation where we are getting that output. So y1 we are getting the output at, so this one I1 and then I3. Okay, I1 plus I3 we are getting. And y1 equal to where we are getting the output equation and then I2 plus I3. Okay, so I3 is common, that's it. Okay, same thing we need to connect that input lines I0, I1, I2, I3. Okay, so I0, I1, I2 and then I3. Connect one OR circuit. Okay, so pass the one line for Y0 output. What are the inputs we are getting? What are the inputs? I1 we are connecting and I3 we are connecting and then another OR gate you can take that. Okay, So pass one line, and then I2 and I3 are connecting, that is Y1. Okay. Then 8 by 3 encoder, same thing, 8 inputs are there, 3 outputs we are getting. Same thing, we are writing the truth table for this. Okay, see, I0 to I7 we are having the inputs. Okay, I0 is selected means Y0, Y2, Y1, Y0 all are zeros, so that is 0. Okay, and then 1, this is 2, 3, 4, 5, 6, 7. Okay, so if I2 means where we are getting the output, so I2 means this is the I2, and then 0 1 0 we are getting the output, and then I3 means 0 1 1. Okay, I4 means 1 0 0. Now tell me what is the output equation. Why not why not where we are getting one side and 3 and 5 7, that means I1 plus I3 plus I5 plus I7, and then Y1 equation where we are getting continuously two outputs like see I2 plus I3 plus I6 plus I7. Okay, and then Y2 where we are getting the continuous ones here, uh, 3 plus sorry 4 5 4 5 6 7. Okay, I4 plus I5 plus I6 plus I7. So this is the output equations. So based on that we need to connect the target and output y not equal to I1 plus I3 plus I5 plus I7. Those are connected here. Okay, understood how I am connecting the encoder 8 by 3 encoder?
No, please, once again, can you?
Huh. See how we are connecting the inputs means, so just check the inputs, 8 inputs we are taking, right? 8 by 3 encoder. Okay, so 8 inputs are I0, I1, I2, I3, I4, I6, I7. Okay, these are the 8 inputs. Every time one input we will select that. I0 I have selected, then 3 outputs I am getting 8 by 3 encoder. So that means 2 cubed by 3. Okay, so 3 outputs I am getting that. So 3 output means 8 combinations we are having, right? So I0 is selected means this is 0 because 1, 2, 4, okay, all are zeros. Because I naught is the decimal value 0, okay, for that 0 binary value 000, output side all are zeros, okay, and then I1 is selecting here, that is 001, that means 1, okay, after that this is 2, then 3, 4, 5, 6, 7. These are the decimal values. Okay, yes. Whenever you are selecting the input I2, the binary is 010. How to write that? This is 2, right? So at 2 position 1 we are getting. And then I3 means, so Y0 and Y1 is the high values because 2 plus 1, 3. Okay, I4 means Y2 is the output side because that is the 4 value, and then I5 means 4 plus 1. Okay, Y0, Y2 and Y1 are Y0 are selecting, and then I6 means Y2 and Y1 will be selecting. Okay, because 4 plus 2 6, right? 6. And then 7 means triple 1, all are ones. Then your output side where we are getting the ones in the Y not case at one position, third position, fifth position, and seventh position. Those are connected to Y not. Okay, and then Y1 where we are getting ones here. Okay, ones we are getting at Y2 side and Y3. Okay, that means 2 and 3. After that, 6 and 7. Then I2 plus I3 plus I6 plus I7. Those are the input side. Okay, and then Y2 where we are selecting the outputs 4, 5, 6, 7. That means I4, I5, I6 and I7. These are the outputs I am getting. Okay. So then we are connecting to one OR gate. That OR gate we are having what are the inputs? I1 plus, I3 plus, I1 plus, I3 plus, I5 plus, I7. Okay, I1, I3, I5, I7 are connected to first OR gate. Okay, and then second OR gate we are connecting I2, I2, I3, and then I6, I7. That's it. Clear?
But
Yeah,
in the diagram of Y1, is Y0 also, I1, yes, I understood.
Okay.
So I was confused with the diagram, but
Yeah.
it's corrected everywhere, we ended.
Yeah. So if you are getting confusion to connect like this, then you can draw the I7, I6, I5, I4, and then I3, I2, I1, I0. Okay, up to I0 is also there. Then draw lines here. Okay, so then connect one OR gate here. Okay, so then pass one line. Okay, then I1 I need to select that I1 side one line and I3 line. Okay, I5 line and I7. We are connecting one into mark. Okay, that into mark represents that connecting that port. Okay, input port. This into mark is represents that connecting the port. And take another OR gate here. Okay, draw the another line, and then for I2, this is Y0 output, and then Y1. What are the inputs we need to select? 2 and 3. Okay, 2, 3 select continuously, and 6, 7. Okay, this is 6 and this is 7. In this way, we can connect.
Oh, yes, this is good.
So priority encoder means, so it gives the priority for that, but who is presenting the most parity bit, most significant bit, that gives the most priority. Okay, so that means highest priority is giving to that, considering that leftmost bit. Who is that leftmost bit is 1. Okay, that is the most significant bit is 1. At that time we are getting 1 here. Okay, so that is the priority encoder. See, same encoder operation, suppose 4 by 2 encoder, how we are considering that 4 inputs and 2 outputs I am getting, right? So like I3, I2, I1, I0, and then Y1 and Y0. Okay, so if all are zeros, okay, so I1 is 1, remaining all are zeros. I0 is 1, and then these output should be 0, 0. And again 0, 0, this I1 is 1, this I0 is don't care value. Okay, why I am taking that I0 is don't care value, this I0 may be 0 or 1, I don't know. Okay, so previous case is 1, but the next case is you are taking 0 or 1, we don't know. So then that is, but highest priority is given to I1 only. Then 0, 1 only we are getting the output equation. Again 0, 1, but I2, I1, I0 also both are don't care values. Okay, both are don't care values, and then Y0 equal to what is the equation we are getting here? Okay, so this equation is 1, 0. Okay, and then this is 1 and this one is don't care value. Okay, so then I'm getting the equation is 1, 1. So based on this, we need to do the K-map for this. Okay, so how the K-map is converted? See, for Y1, for Y0, where we need to consider ones here. Where we need to consider ones means Y0 is that values we are getting, that is the D2 bar, sorry, Y0 we are getting at the output like D1 and D3, right? So D1 case and this is the case, D1 case and D3 case. Okay, D1, what are the combinations we are getting? 0 0, sorry, 0 0 1, don't care. That means 0 0 1 0 is the one case, and 0 0 1 1 cases. That means at 2 position and 3 position, 2 and 3 I am getting once here. And then another input is D3. Okay, so third position, that is 1, don't care, don't care, don't care. That means 1 0 0 0 case, 1 0 0 1, 1 0 0 1 0 1 0, okay, 1 0 double 1, and then 1 0 1 1 0 0. Okay, so again 1101, 1110, all ones. That means 8, 9, 10, 11, 12, 13, 14, 15. All positions we need to write once here. That is the reason where we are writing once here, third and second. So D2 and D3 are ones, and all are 8. This is 8, 9, 10, 11. Okay, so 12, 13, 14, 15. All are ones. Combined together form a Boolean expression. Okay, so tell me this Boolean expression, what is the common variable here? D3 and D2. This is D3 and D2. D3, D2 bar. Okay, what is the common variable here? D3, right? Okay, we can write D3, and then all combined together we get 1 only, and then forming a quadrant here. These two are making quadrant, so then combined together, what is the variable we are getting here? This is D1 and D0, D1, D0 bar. Again D1 is the common here, and then what is the common variable here? D3, D3 bar and D2 bar. Okay, D2 bar is the common. D2 bar into D1 is the output. Okay. So in this way, the priority encoder we are getting values. Okay. So same thing. I am getting the equations like this. Okay. So the priority encoder we are having values. What are the where we are getting the values here? Okay. So 8, 9, 10, 11, sorry, 8, 9, 10, 11, 12, 13, 14, 15, because where we are getting the one for this y1 at second position, this is the ones we are getting. That means 0, 1, don't care. That means 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1 case. That means 4, 5, 6, 7. Okay, and then rest of the values. These are the rest of the values. 8, 9, 10, 11, 12, 13, 14, 15. So then from 6 to values we are writing here. Okay. So from 4, okay, this is 4, 5, 6, 7, and then 8, 9, 10. So forming a 2 octanes. This is one octane, this is another octane. Okay, 2 octanes we are forming. Then group together forming a values D2 and D3. Clear?
Sure.
So this is the parity generator. Parity generator or checkers. What is that? Parity generators or checkers means what? See, imagine you are sending a message to your friend through a some noisy channel like so optical fiber you are taking. Optical fiber is noise free. Some coaxial cable you are considering means so the data is transmitting some noisy. Or compared to the coaxial cable, twisted pairs are more noisy. Okay, so then if you are transmitting the information through this twisted pair means you are getting some noise, right? So based on that, I want to transmit the information 1011, but you received that 1001. Then you may get receiving bit may be error, right? So that bit uh, is changing. One bit is changing. How I need to know? So how the receiver know if you are received correct bit or incorrect bit? So based on the parity, we will find that error. Okay, one bit error we will find that based on the parity number. Okay, so if you are taking that parity bit either 0 or 1, then append that value to this parity. Okay, so suppose if you are considering even parity or odd parity, based on that we will add 0 or 1. Okay, clear? So basically parity bits are used to identify the errors. Okay, where we are getting the errors, that we need to identify, and then it will check that which position we are having errors. Okay, so that is the purpose we are taking this parity generator or checkers. Okay, what?
So,
Tell me.
no, I'm just asking a question in between because so parity generator or parity bit, it can be used to send that WhatsApp messages which we're sending for
So whatever,
coded
yeah, whatever the bits you are transmitting from the transmitter side to receiver side, so one bit is corrected means we need to identify that. Okay, we need to identify that and again retransmit it. Sometimes we are doing some transactions, it is failing, right? So based on the network issue or any other, or scanning is mismatch, all these things. Okay, same thing. Sometimes we are sending the information from the transmitter side to receiver side, but receiver is not receiving properly the information. Okay, so due to that, some blurriness in your image or some network issue in your side. Okay, all these things. Based on that, we are having some issues. Okay, clear? So that issue will be taken by this parity generator or parity checker. Okay. So give me a minute. I will. So here, this is the parity. What is meant by parity? What is the use of that? It is adding extra bit to your data. Okay. So based on that, suppose if you are considering even parity or odd parity or which parity we are considering, based on that we are getting some what it called bit extra bit will be added. Okay, so the parity bit is an extra bit added to the data before transmission. Okay, before transmission we are adding some bits, that is the parity. Okay, what is the purpose of that? Detects the transmission errors and detects single bit corrections. Okay, every time we are getting single bit error, then parity is the best option to detect that errors. And then very simple hardware implementation, that is the parity. See, just exclusive OR gates we are using that. Okay, this exclusive OR gate, based on that we are identifying the parity where we are getting the error in your data transmission while transmitting that bits, where we are having the error. Suppose 1011, I am taking that this is 10 and take the another exclusive OR gate. This could be connected here, and another input 1. After that this is also connected to another exclusive OR gate. Okay, so the bit is connected to 1. Okay, so suppose you are taking odd parity, then there is no need to add that value, because odd parity, what is the values we are getting? 10 exclusive OR gate 1 here. Okay, 110 here and 011 here. Okay, so then 1101 will be transmitted. Okay, so then odd parity will considered means 1011. Okay, then 0 will be added here. No need to add any other bits, because you are considered the odd parity. But you consider even parity. How I am saying that this is odd parity? Based on the number of ones. How many ones are there here? 3 ones, right? See, 3 ones are there. So 3 ones are there means the number is odd. So there are 3 ones which is an odd number, right? Or 3 is an odd number. Then odd parity you are checking that. Then the transmitting side is 1100. Sorry, 10110 will be added at that first position. Okay. Then no need to add the any bits. Otherwise, if you are considering the even parity means, because here odd number of ones are there, I need to add 1 0 triple 1. Okay, so 1 0 triple 1, I need to add that, and then we will get that output here. Okay, clear? Any doubt from this parity generator? Even parity and odd parity. There are two types of parities are there, even parity and odd parity. So even parity means even number of ones we will consider that. Odd parity means odd number of ones we need to take that. Okay. So then here 1 0 1 1 I'm giving the inputs. Three ones are there. If you count that even parity, so then you need even count, one parity bit will be added. Then you are transmitting like 1 0 triple 1. Okay. Or odd parity you are considering means, see now here four ones are there, then even number of ones is there, then no problem here. Okay, then while transmitting the bits, we are getting 0 here because exclusive OR gate you are adding here, so that is 1 0, and again another exclusive OR gate you can consider that here 1 is the output, and then again 1 I am giving, I am getting the 0 output, and then another input, I'm giving 1 here. Okay, so then 1 0 exclusive OR operation, I'm getting 1 here. After that I am giving to another exclusive OR gate, then 0 we are getting. Okay, so
even count is there, you need odd count.
then you can add 1. That's it. Suppose even number of ones are there, this is even number of ones, then you need to convert into odd parity. So odd parity means again 1 0 triple 1, you can add 1 bit here. Then even number of ones, odd number of ones will be there. Odd number of ones will be there means odd parity you will consider that. Even parity the output should be 0, odd parity the output should be 1. Clear? Hmm. That's what. See, odd parity generation, already three ones are there here, 1 0 double 1. Then three ones will be odd number, then parity bit will be 0. Then no need to add extra bit for this because three is the odd parity. Then maintain same code, 1 0. See 1 0 double 1 0. Then this 0 will be added at the front. This is the parity bit. Okay, before transmission of the data only we are adding one extra bit. That bit we will consider that either even parity or odd parity. Based on that we will remove that bit at the receiver side and consider that next bit as a data bit. Okay, whatever the data bit we are transmitting. See, this is the parity generator and checker. See, the data, what are the values we are having, that will be added together here. D0 and D1 is giving here, and then D2 is connected to another XOR gate, and D3 is connected to another XOR gate. If you want, then the receiving bits are here, and then the parity bit is here. Okay, to receive the bits is here, and then parity bits will be added here. This parity, based on this received bits, if you are considering odd parity, then even number of ones are there, you can add parity bit is 1. Okay, so you are receiving odd number of ones, and you want even number of ones, you want to convert that odd parity, then add 1 here. Okay, so based on that we will get that. So if we are getting 1, then you are having an error in your data, then that is the reason we need to add one parity bit, then should be converted to 0. So that 0 is present at the output side means there is no error in your data. Okay, he will consider that, he will do the exclusive OR operation at the receiver side, whatever the data we are transmitting. So based on that even parity or odd parity, we are checking the error in your data, whatever the data we are sending from the transmitter side to receiver side. So we check that data at the receiver side. If you are getting the output is 0 while considering the even parity, then there is no error in your data. Clear? Hello. So next, even parity can check these values. Okay. So what are the inputs I'm giving here? Give me a minute. Cursor is not visible. See, I'm considering the even parity. Okay. My inputs are 1, 0. Then even parity, I have added 1 here. Then odd parity 0. Okay. And then 1, 0 I am giving. Then this is the even parity. This is the odd parity I want to check. So for odd parity, we need to add 1 here. Okay. Sorry, the reverse side. Odd parity. We don't want to add values here. Okay. Okay. Then 0 will be there. If you want to convert into even parity, add 1 here. Okay. And then even again 0 1. Okay, so then we need to get the output like this. So even means again we need to add 1 here to get to convert into even, otherwise odd parity even value will be 0. Okay, this is the outputs conditions. Okay, don't care values means we will consider as a 1 or zeros. Okay, if you consider all zeros means both are ones will be added here. Okay, so even parity, don't no need to add 1, and odd parity we need to add the value here. Okay, so this is the sum of even numbers. The outputs will be sum of even numbers means how many ones are there here. For even parity, one value we need to add. Okay, for odd parity, the output will be 0 if you add 1. Okay, and then 1 0 means, so even parity, odd parity, you are checking that sum of ones will be 1. For the odd parity, we need to add 1 value. Okay, that is the condition. See, designing the even parity of 4-bit generator, 4-bit input. How we can expect here? See, these are the inputs I am taking. Okay, so 4-bit input means 16 combinations I am getting. 2 power 4, 16 combinations. 0 0 0 0 to 1 1 1. Okay, so then odd parity, what is the value we are getting? So 0 0 means all are zeros. Okay, so, you are checking that even parity, right? So then they need no need to add any one bit here. Extra bit is no need to add here. Okay, all are zeros. Then even number of ones are there. Then 0 will be added. 1 1 is there. You can add 1, and then 1 1. So you can add 1. Even ones are there. 2 ones are there. Then output should be 0. Okay, so odd 1 is there. Then add 1 bit. Okay, so 2 ones are there, 0. Again 2 ones, 0. 3 ones we need to convert 1 here. And again 1. So 0, 0, 1. Okay, 0, 1, 0. Sorry, 1, 0. So where we got ones here, based on the values, we need to find the K map and then find the output equation here. Okay, so that output equation where we are getting, just see this is the output equation. 0, this is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so where we got ones at one position, we have 1 here, and then 2 added 1 here, and then 4 added 1 here, and then 6 7 added 1 here. Okay, and then 8 added 1 here, so this is the 8, and then 11, so added 1 here, and then 13 14. Okay, 13 14 added ones here. Then tell me the Boolean expression. See, there is no need to form the pair, quadrant, octane, all these possibles. Only single values we are getting. Then simply we can write that. What is the equation we are getting? A bar, B bar, C bar, D. Okay, A bar, B bar, C bar, D. And then next one, A bar, B bar, C, D bar. Okay, and then third one, A bar, B, C bar, D bar. Okay, A bar, B, C bar, D bar. And then fifth one, that is 7 means 0 triple 1. So 0 triple 1 means,
A bar B.
okay, 0
C
triple
D.
1 means A bar, B, C, D, right? That is here right, written wrong maybe. A bar, B, C, D. This is A bar, there is no bars here. A bar, B, C, D. Okay, and then eighth one, what is the eighth one we are getting here? I think this is eighth equation I have written. Okay, so this is eighth equation, 1 triple 0, 8, and 9 means 1 0 0 1 0. Okay, 0 0 1 0 means 2, right? Okay, so this way is written. Uh, Maybe somewhat difference is there. You can write directly where A bar, B bar, C bar, D, that is 0 0 0 1, and then A bar, B bar, C, D bar. Okay, so at one position and then two position. Okay, and then again add together values. Okay, where we are getting 1 here, A bar, B, B, C bar, D. Okay, in this way we can write that. So this is 4 0 1 0 0, fourth position, and seventh position means A bar, B, C, D. Okay, so then form on the variables and form the exclusive OR gate operation. See, what are the common variables here? First two values, A bar, B bar, we can get the common variables here. Okay, A bar, B bar is the get common, and then C bar, D is the values we can write there. Okay, see, this is A bar, B bar, and this is A bar, B bar, common these values. Okay, what are the variables we are come? C bar, D, and C, D bar. C bar, D, C, D bar means A XOR B, sorry, C XOR D. Okay, that is the exclusive OR operation, and then A bar, B bar is the output I am getting. Clear? Any doubt in this? Similarly, what another two equations? What is the equation we are having here? A bar B is the common. A bar B is getting common, and then C bar D bar plus CD. Okay, C bar D bar plus CD means what is the equation here? A bar B bar, and then C XOR with D. Okay, plus A bar B is the common variable. This is the exclusive NOR gate, right? That means C bar D exclusive NOR gate. Okay, C XOR D whole bar we can write that. Clear? So then four values I have written, and then rest of the four values I need to write here. Okay, what are the rest of the four values? Uh, 8 is there, right? That means A bar, sorry, not A bar, A, B bar, C bar, D bar. That is the 8 value. And then 9, what is the 9 value here? A bar, B, sorry, A, B bar, 9 means 1001, right? A, B bar, C bar, D. Then common the values, what are the common variables? A, B bar is the common. A, B bar is getting common, then C bar, D bar plus C bar, then what is the common we are getting? Then not getting any common, right? So 9 we are getting, that is C bar, D bar. Okay, we can write another two equations also. What is the another two? 13, right? So 13 means 1 1 0 1. Okay, A B C bar D plus and 14. 14 means triple one. A B C bar A B C D bar. Okay. A B C D bar. Clear from this? Okay. So we will go through this one. A B bar C bar D is the common and A B gets common here. Then C bar D plus C D bar. Okay. That is okay. And then here only we are getting something. Uh, what is the value we are getting? So 8th value, right? 8th and 9th, not 9th, 11th, right? Here 11th value we are getting. See, 11 means what is the value? Uh, so 11 means so 1011, right? So then CD. Okay, so then CD is the common. So A B bar C bar D bar means C exclusive or with D whole bar plus what is the other common variable? A B is the common, then C XOR D is the output. Okay, clear? Then C XOR D, C exclusive or D. So then check the common variables here. C XOR D is the common in every variable. Okay. So what are the common variable you can have? Then you can get the common. After that, A bar B bar A bar B A B bar A bar B. Okay. A bar B bar means again exclusive OR gate. Okay. Exclusive OR gate and A B bar means exclusive OR gate. Okay. A bar B is the output. Any doubt in this? So if you have any doubt, so just you can take the individual values. Okay. So write the equations where we are getting the equations. Then I will write here. Okay. Just um, the even parity values at even parity one position and then second position. After that fourth position and then uh, 7th 4 comma 7 and then 8 after that 11 okay after that 13 and 14 okay these positions we need to add the parity values so then a b c d I am taking right so what is the conditions a b c d means a bar b bar c bar d that is one value and another value is a bar b bar c c d bar and fourth value means a bar b c bar d bar plus what is the seventh value a bar b c d okay what is the eighth value a b bar c bar d bar and what is the 11th value a b bar CD. Okay, so 8 plus 2 plus 1, 11. And then 13 means A, B, C bar, D. And then A, B, C, D bar. Okay, then common the variables here from this A bar, B bar is the common for the first two variables. A bar, B bar gets the common here. C bar, D plus C, D bar. And again the next two variables we can common the a bar b is the common variable and c bar d bar plus cd and then next two variables a b bar is the common variable and then c bar d bar plus cd okay again what is the other variable here Hmm. ab is the common c bar d plus cd bar okay write the other another equation for this a bar b bar and this is the exclusive OR gate c XOR d and a bar b okay c exclusive NOR okay then a b bar Okay, C exclusive NOR. Okay, again A B C exclusive OR. Then first term and last term you can common that C exclusive C XOR with D. Okay, you can common that first variable C exclusive OR with D. Then what is the other variables we are getting? First and common A bar B bar plus AB. Okay, so then second and third, what is the common variables we can take? That C exclusive NOR. C exclusive NOR with what is the common A bar B plus AB bar. Okay, so then you can tell me here C XOR D and then A bar B bar plus AB bar. That means A exclusive OR with A exclusive NOR with B. That means C XOR D and then A exclusive NOR with B. Okay, again C exclusive NOR with A XOR B. This is A XOR B. Then check this. This is A, this is B, A bar B bar plus this is A bar and this is B. Then A B bar plus A bar B, A XOR B. So this A is what? A C XOR D, right? C XOR D exclusive OR with A XOR B. Okay, then we got A XOR with B XOR with C XOR with D. Understood how I am getting that A XOR B XOR C XOR D? So same thing he is written here. Okay, A XOR B XOR C XOR D. Clear? Any doubt from this? From the bridge?
No.
Huh. See Hamming code. So how the Hamming code is performing here means same like that, but depends upon the data. Suppose data bits, 4 data bits they have given like D3, D5, D6 and D7. So this is 4-bit parity, 4-bit message I am giving. I am having 4-bit message. Any bit, either 1011, 4-bit. Then how many parity bits we need to add to transmit the Hamming code? So Hamming code is that used to correct the data. Okay, whatever the data we are transmitting, parity bit is checking that error, where we are getting the error. And then Hamming code, it will correct that error. Okay, it will correct that error and transmit the original data. Okay, corrected data will be transmitted through Hamming code. Okay. Just give me here 4 bits are there means then what is the formula here? 2 power p greater than or equal to m plus p plus 1. So 4 bits are there, right? 2 power p greater than or equal to 4 plus p plus 1. Okay, so then p value we need to decide that. I am deciding p equal to 3. Why I am decided that p equal to 3? 2 power 3 is the 8 value, right? So 8 greater than or equal to 4 plus 3 plus 1. Okay, 4 plus 3 plus 1 means 8. 8 greater than or equal to 8. Condition true. Then how many parity bits I need to add? 3 parity bits, but the place is P1, P2 and then P4. That is the reason D3, D4, D5 and D6 data are there. Okay, so P1 I don't know value, P2 I don't know value, D3 I know 1, P4 also I don't know, and D4, sorry, this is D5, this is P4 and D6, D7. Okay, so D5 I know that 0 and D6 is 1, D7 is 1. Based on this parity bits we need to calculate that. P1 starts from 1 and 1 bit leave 1, 3, 5, 7. Okay, up to this value we need to write that. And then 1 position is there is no value, empty position we can write that. And then third position, what is the value we are having? 1. Okay, 1 and then fifth position 0, seventh position 1. If I considered even parity, then there is no need to add here bit here. Okay, 0 only we can take that. And then P2, 2 comma 3, 4, 5 we can leave that, 6 comma 7. Okay, 6 comma 7. Then P2, 2 position I don't know the value, and then third position 1 is there, and sixth position 1 is there, seventh position is 1. Then even parity I need to add 1 here. Okay, then P2, P4, P4 position, what is the value we are having? 4, 5, 6, 7. Then 4 values we can continuously write that, and then 4 values we can leave that. Okay, and then fourth position I'm having empty position 5, 6, 7, that is 0, 1, 1. Okay, so 0, 1, 1, then you can add 0 here. Then what is the position we need to add here? This is 0, this is 1, and this is 0. Okay, second bit position I need to add 1. Okay, 0, 1, 0 means 0, 1, 0 means second position. This is 1, 2, 4, right? So then this value is 2. Then at 2 position I need to add 1 and then transmit the data. Okay, so this is the way we can correct the error. That is the Hamming code. Here, any doubt?
Not yet.
So comparator will compare the two values. Okay, so then I am getting the three outputs like less than, greater than, and then equal to operation. Okay, so less than condition, equal to condition, and then greater than condition. Okay, here it will check each and every bit. Suppose A naught and 1 bit comparator, right? So 1 bit, that means A naught and B naught is the values. Okay, A naught greater than condition, less than condition, equal to condition. Suppose this is my A naught and this is B naught. Okay, if A naught is 0, 0, so both are equal, right? Then 0, 0 means both are equal. Then what is the value? Equal to condition I am getting 1 here. Okay, here is considered that A naught and B naught. So 0, 0 equal to condition I am getting that. 0, 1 A is less than, right? Okay, A less than B. Less than B I am getting 1 here. And 1, 1, okay, so 1, 0, again A greater than B. Greater than condition I am getting 1 here. 1, 1 means, okay, equality condition. I am getting 1 here. Okay, so based on that I will write the equation here. So less than condition only one condition I got, that A naught bar and A B naught, and equality condition A naught bar, B naught bar, and A naught and B naught. That is exclusive OR gate operation. Exclusive OR gate operation. After that, greater than condition only one value we are having, that is A naught and B naught bar. Okay, and again greater than condition and again I am considering that. Okay, so this is 1 bit comparator. Similarly, you can do that 2 bit comparator also. Okay, so 2 bit comparator means A naught, A1 and B naught, B1. In this way we can consider that. So 4 combinations 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, so 0, 0, 1, 1 up to 16 values we can write that and then check that greater than, less than, and equal to operation. Okay. So up to this it is over. Okay, this is the multiplexers representation. How the multiplexers are implemented for full adder, half adder, full subtractor, all these things. So here some output I'm adding here. So 3 bits I'm considering. So S0, S1, S2, 3 select lines. Then 8 combinations I'm getting the outputs here. Okay, so for 0 0 0 output is 0, 0 0 1 output is 1, because he's exclusive OR gate is considered there. Okay, so because full ladder, what is the output I am getting here? For full ladder, A XOR B XOR C I am getting, that is the sum output. If you want to do the carry also, for carry, what is the output, where we are getting the output? This is 0, this is also 0, and this is also 0. Here I am getting 1. Fourth position I am getting 1, and then fifth position I am getting 1. Okay, sixth position I am getting 1. Seventh position I am getting 1. Fourth, sorry, 4 is not getting, right. Third, see, this is 0, this is 0, and this is 0. Third I am getting 1, fourth 0, and then 5 1, 6 1, 7 1. Okay, so what is the sum of equation here? We can write, for sum, where we are getting ones, at one position, 1 comma 3 comma, sorry, 1 comma 2 comma 1 2 4 6, 4 7, 1 2 4 7, right. At one position, this is 1, and this is 2, and then 4, and then 5 6 zeros, and 7, 1 2 4 7. That is the sum output I am getting, sigma m 1 comma 2 comma 4 comma 7. And then carry output, where we are getting sigma m equal to, uh, here third 3 5 6 7. These positions I am getting 1. Then draw the multiplexer here. Okay, so that is 8 by 1 multiplexer I am drawing here. This is the 8 by 1 marks. 3 select lines I am having, S0, S1, S2, A, B, C select lines I am taking here. Okay, because A, B, C I am connecting here. And then 8 inputs, D0 to D7. 8 inputs are there. Okay, so where we got ones here? For sum output, sum and carry I want to design here. Okay, so here you will get confusion, means draw the 8 by 1 mux here. Okay, 0 1 2 3 4 5 6 7. This is 0 1 2 3 4 5 6 7, and 3 select lines you can consider that, S0 S1 S2, that is A B C, and one output I am getting here. And then draw where we are connecting the ones here, where we are getting ones. For some output, at one position I am getting 1, and then 2, and then 4 7. Okay, all these are all these are connected to some output, some input. Okay, and then rest of the things, what are the rest of the things? 3, so for 3, and 5 6 7, this is also connected to carry. Okay, these are all connected to carry, and rest of the values will be connected to 0. So only one value is there, that is 0. 0 is already connected to 0. Okay, this 0 is connected to 0. Clear? This is the full ladder representation by using mux. Okay, and then he is giving one condition like this, where we are getting ones here, 0 and 1 2. So 0 1 2, and then 3 4. Okay, after that 10 11 14 15, 10 11 14 15. So here he is giving this sigma m value. Suppose f of a comma b comma c comma d equal to this value is given. Design that for 16 by 1 mux, we can use that. Okay, for 16 by 1, 4 select lines are there. 4 select lines are A, B, C, D, all are select lines. Okay, so consider that values where we are getting ones here 0, 1, 2, 3, 4, 5 up to 16 up to 15 we can write that where we are getting ones at 0th position 1, 1 position is 1 and 2 1, 3 is 1 also 5 1 and rest of the zeros here. Okay, and where we are getting 1 10, 11, after that 12 and 13 are zeros, after that 14 is also there. Okay, I missed this value 14 comma 15. Okay, so 14 comma 15, this is direct question 16 by 1 marks, but they will ask you to design this value with 8 by 1 marks. Clear? 8 by 1 marks we can design that. Okay, so for this how we can consider the values means just check this values where we got ones here, where we got ones in the one side two combinations I will consider here because this d value I am not considering. See, this a value only, abc value only I am considering. These are all zeros, two conditions I am getting for 0. Okay, for 0 d naught is 0 and d is 0 and 1, but here I got ones here 2 outputs are 1 means f output is 1. And then again 0 1 case, 1 case means 0 0 1, this is the one case, two combinations we can form that. Again here also 0 1, and then both are ones means no problem, output is 1 only. Your output is both are ones means there is no problem in that, but here it can, there is a problem 0 1 0 0 1 0, this is two condition. And then check this d value, this is 0 and here 1 I am getting, this is 1, here I am getting 0, that means the output is complement of d, that is f equal to d bar. Clear? And similarly uh, third value, third value also you can check that. So this is third, f is 0, d is also 0, f is 1, d is 0. Okay, so d is 1, f is 0. Then see, though both are zeros means 0 only we can consider that, not presenting means no problem. Okay, single one is present means then we can check that. And then both are ones means you can take the output is 1, both are 0 means you can take 0. Okay, output is 0, then this condition you can check that 1 0 0 0, that is fourth condition. See, both are zeros again, output is 0. And then 0 1 0 1, both are ones, output is 1. Again both are zeros, output is 0, both are ones, output is 1. Okay, so in this way, so where we are getting stuck here, this d bar, how this d bar is getting here. Okay, check this value, 0 is converting to 1, 1 is converted to 0, that is the reason d bar I got that. Okay, and the rest of the values is connected to 1, so where we are getting the ones here at 0th position, 0th position, first position, and then this is 5th, this is 6th and 7th. 5th and 7th I am having ones here. Okay, sigma m 0 1 5 7. Okay, so 0 1 5 7 are connected to 1. Okay, and then where we are having again ones here, so there is no ones, remaining all are zeros. Okay, zeros where we are having sigma m of 0, this is ones, and zeros where we are having 3 3 6, that's it, right? 3 6 3 4 6, right? This is 3, this is 4 and this is 6. Then 3 4 6 is connected to 0, and only one value is there, that is d bar. Okay, d bar is connected to 2, so 2 is connected to d bar, that's it. In this way we need to design our 8 by 1 marks, okay, 16 by 1 marks by using 8 by 1 marks. Clear? Any doubt up to this?
No, sir.
Okay, listen this video and then you can ask me the doubts. I will clear that. So this is all about the combinational circuits. Okay, the next class we